Good day, welcome back. We are looking at the second part of analytical geometry where we look at the gradient of a line. It's our first video on this topic and we are looking at the steepness or the indent or the rise of a hill over distance. If something rises by a height of 1 meter over a distance of 1 kilometer, it's not too steep. But if something rises by 1 meter in a distance of 1 meter, then that would be relatively steep. So, in order to explain this, I'm going to show you an image of a mountain and how this effect is brought about. When you are going to climb this mountain, then you will start out at a very easy slope. It will be easy. And as you go along, this mountain becomes gradually steeper. Until a point where you can no longer just rely on climbing or walking, but you will have to pull yourself up. So much so that it will get to a point where you will have to use ropes to scale the mountain further. Then I get another steepness, and then when I get to the top, then it will plane out. So when I speak of the gradient of a line segment, I am referring to how steep the slope is of anything. This is what gradient refers to. So if my distance is short but I have an increase, I will see that that slope is very steep. But if the distance is increased for the same gradient, I see that it becomes very shallow. It's not as high and steep as it used to be. It pans out. So the further I go for the same height, this will relatively become an easier slope. So much so that you can walk up the slope compared to having to climb up the slope if it's a very steep rise over a shorter distance. So that one compared to this one, the steepness much steeper in this one. So if I look at the coordinates of point I, which is -3 and +3, and I look at the coordinates of point D, which is 3 and -1, and I want to calculate the slope between these 2 points. What is the slope of this line? I will have to see what is the change in Y over the change in X. So I'm looking at the rise of this graph over a distance. So let's calculate. So if I move from I to D, I would have to move 4 units down, and I would have to use 6 units across. So if I have to display this gradient, so when I calculate the gradient, I say gradient, which is M abbreviated, the abbreviation for gradient, is equal to delta y over delta x, meaning the change in y over the change in x. So how much does y change in comparison with the change in x? So if I calculate the gradient of ID, line segment ID, then I will take 3 minus -1, and I will have that over -3 minus +3. So that will give me negative 3 minus 3. That gives me minus 6. That on top gives me plus 4. Simplified, it will give me negative 2 over 3. But I could have alternatively decided to calculate the gradient of di. So if I had done the di, I would have had minus 1 minus 3. That will give me minus 4 over 3 minus 3, which will give me 3 plus 3, 6. So that will also give me negative 2 over 3. So it does not matter which one I choose to make y1 and which one I choose to make the second coordinate. Does not matter. It will give me the same result. But I must remember, whatever y2 I have, the corresponding x at that value must be x2. Let's quickly look at the gradient of line GE. If I notice that gradient is m is delta y over delta x, meaning the changing y over the changing x. So how much does y change compared to the change in x? So y, I can see, changes 3 in a negative direction, and x changes 6 also in a negative direction. A negative over a negative will give me a positive. So let's use the coordinates. So my y value, 1 minus 4 is minus 3, minus 5 minus 1 is minus 6. So that will give me a half. When I went and I said GE, where E is now my second coordinate, then it would be 4 minus 1 over 1 minus 5. So that minus, remember, put in brackets because we can't have two symbols standing next to each other. So minus multiply with the minus, the plus. 1 plus 5 is 6. 4 minus 1 is 3. 3 over 6 simplified becomes 1 over 2. So the gradient or the slope of that line is 1 over 2. What does this mean? For every 1 unit that y rises, x will move 2 units over. Let's quickly see if this is true. So if I move from this point in that direction and I say y rise 1, how far did x move? Oh, it moved 2. So if I see from this point that way, y rose by 2. How far did x move? 1, 2. So 2 of the same units for every one of the y units. Can you now try to calculate the gradient for each of the following line segments: AL, KC, JB, GE, IF, using the formula M is equal to y2 minus y1 over x2 minus x1. Good luck. Thank you for watching the video. If you like to tell your friends, if you loved it, tell everyone. We'll see you in the next one. Do not forget to like, subscribe, and to turn on your notifications to be notified when the new video is uploaded. Share if you found it useful. Goodbye.